Okay, so we were just talking about theoretical probability and complements of an event. Now I want to talk about compound events. Compound events is when you have more than one thing happening. So far we just talked about what if one thing happens. So you roll a die and you want to get a 5. The probability would be 1 out of 6. Okay, now what if I want to do a couple of things? So here I have a couple of things happening. So my example, I'm going to make a table of the possible outcomes, that's called a sample space, when tossing a coin and rolling a die. Okay, there's a couple ways we could do this. We talked about this in my class. We could make a tree diagram, so that's, a lot of people like making a tree diagram. So tossing a coin and rolling a die, so you could have like heads, tails, and then if I toss a heads and then I roll my die, I could have 1, 2, 3, 4, 5, 6, and same here, 1, 2, 3, 4, 5, 6. Okay, so that's one way of organizing it. But for my notes, I'm actually going to make a table. So let's see, do I have my straight edge handy? Of course not. Why would I? All right, let's just use somebody's name card here. So I'm going to make a table, and I'm going to have my heads and tails over here on the left-hand side, and my tossing the coin up on the top. Okay, so I'm going to have my coin, I could get heads or tails, and then for my for rolling my die, I could have a 1, I could have a 2, a 3, a 4, a 5, or a 6. Oops, ran out of room. All right, so what could happen? If I toss a coin, it lands on heads, so we'll call that heads, and here's my coin. Here's my die. It could land on a 1, so I could get heads and a 1, or I could get heads and a 2, or I could get heads and, where is it? Does this have a 3? Yep, a 3, or a heads and a 4, or I could get a heads and a 5, or I could get a heads and a 6. Okay, but what if this had landed on tails? Well, I could have a tail and a 1. I could have a tail and a 2. I could have a tail and a 3. I could have tails and a 4, tails and a 5, and tails and a 6. So those are all the possible things that could happen when I am looking at these two objects. So we call this a compound event. It's not a simple event, there's more than one thing happening. All right, so how many outcomes are there? So if I look at all my outcomes, it's these guys in here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes. Okay, so in my classes, we were talking about, is there a fast way of getting the number of outcomes if you know what are the number of things that could happen? And we said, yeah, there are. Okay, we know from the coin how many possible things could happen when we toss the coin. There's 2 possible outcomes. And if we roll a die, there are 6 possible outcomes. And if we multiply those together, we also get 12. And notice you can see that it kind of makes this little multiplication table. Or a rectangle, and this side is 2, this side's 6, and the area of the rectangle is 12. Okay, so it's like the area of the rectangle. Number of outcomes on the coin, number of outcomes on the die gives me the total number of outcomes, 12. Okay, so that's important because now we're going to find the probability of certain things happening. And notice the notation here. I want to know the probability of getting heads and a 4. So I need to get both heads and 4 in order to win. So if I look on here, where do I see heads and 4? I see it right here. There's heads and 4. Okay, this is another way of writing that. Heads, and this is intersecting with 4. So this means the same thing as and. I have to have both of these at the same time. We call this an intersection. Okay, so I want both of them. Well, that only happens once. So it happens 1. And how many outcomes did we say there were? We said there were 12. Okay, now let's break that down. What was the probability of just getting A? Okay, A would be the heads. Okay, so if we're talking about A and B, heads is the A, 4 is the B. So what's the probability of just getting heads? Well, if I'm just looking at a coin and I say one side's heads and one side's tails, then the probability of getting heads is 1 out of 2, because there's two sides to the coin, but only one of them is a heads. All right. Event B. Event B was rolling a 4. So what's the probability of getting a 4? Well, there's 1 4 on the die out of 6 possible sides. Okay? So we're going to fill in this little table here. All right. What's the probability of getting heads and an odd number? Okay, so now I'm looking for heads and an odd number. I'm going to use a different color here. So heads and an odd number. If I look for that on here, heads and 1, that's odd. Heads and 3, that's odd. Heads and 5, that's odd. So I have 3, and there's still 12 outcomes. Okay, let's break it down and look at them one at a time. Probability of A, well, getting heads is the A. So the probability of getting heads, again, is 1 out of 2 on a coin. There's only 2 sides. And the probability of getting an odd number, okay, on my die, how many odd numbers do I have? I have 1, 2, 3. 1, 3, and 5. So I have 3 out of 6. Okay? Now the next one, probability of getting tails and a number that is greater than 1. Tails and something greater than 1. Okay, so I'm going to use a different color. Okay, and notice my notation again. I'm using this is called intersection of tails and a number greater than 1. So if I find those on here, tails and a number greater than 1. So 1 doesn't count because that would be equal to 1. So greater than 1, that would be this one, this one, this one, this one, and this one. So that would be 5. So that gives me 5 out of 12. So what was the probability of just getting tails? Well, that was 1/2. What was the probability of getting a number greater than 1? Okay, everything on here is greater than 1 except 1. So this is kind of the idea of the complement of an event. I know the probability of getting 1 is 1 out of 6, but I don't want the 1, I want everything else. So everything else would be 5 out of 6. So I'm kind of using the idea of a complement to help me fill that in. Okay, and the last one, probability of getting tails and a number that's less than 3. Okay, so tails and a number that's less than 3. Need a different color here. Tails and less than 3. So that would be this one and this one. So those ones are tails and a number less than 3. It doesn't say equal to 3, so I can't use that one. So that would be 2 out of 12. So what was the probability of getting tails? Again, 1/2. What's the probability on a die of getting a number less than 3? Well, the only numbers less than 3 are 1 and 2. So that would be 2 out of 6. All right, so why did we set up this table? Because I want you to notice something. What do you notice about the relationship between the probability of the individual items and then the probability of both objects happening? Okay, so what do we notice about 1/12, 1/2, and 1/6? So you should be able to see that if we multiply the two individual probabilities together, we get the probability of the compound event. 1/6 times 1/2 is equal to 1/12. Okay, so if we multiply these, 1 times 1 is 1, 6 times 2 is 12. Okay, so the individual events, if we multiply their probabilities together, we get the probability of the compound event. And it happens every single time. Okay. So what general statement can I make about this? I can say that the probability of A times the probability of B is equal to the probability of both of those things happening at the same time. Okay, that compound event. All right, going to take another quick break.